Hi guys, welcome back to the RQ Studio. In this video, we are going to be learning about joins. I'm sure some of you may be wondering what joins are. So imagine you want to connect two tables together in order to be able to analyze data or pick one data from one table and compare it against another table based on a unique identifier, maybe an ID column and such. In Excel, you would have made use of the XLOOKUP function or the VLOOKUP function. However, in SQL, you will make use of joins. There are different kinds of joins. We have the inner join, the left join, the right join, and the full outer join. And that is what we will be learning about in this video. So let's dive right in. So in my dummy database, I have uploaded two sample tables that we are going to be using for demonstration purposes to understand joins. We have the customer table and we also have the customer sample and the order sample, right? So I have already executed to run my dummy DB, and I'll just preview the tables so we know what data exists in them. So the customer table, in the customer table, we have 4 rows of data and 3 columns. We have the customer ID column, the customer name, and then the country. Now in the orders table, we have the order ID, the customer ID, and the order amount. Now comparing these two tables, I'm just going to run these two queries. So at a glance, we can tell that the unique identifier between these two tables is the customer ID. Now you can see that there are two IDs that can be found in the customer table that have placed orders, and hence they can be found in the orders table, right? And these orders are in the form of 3 rows of transactions, right? So imagine I want to generate a report that gives me the name of the customer and the order ID and the order amount of the customer. I would make use of joins to generate that information, right? So I'm going to start by demonstrating how to make use of an inner join. And this is the format the inner join takes. Select from inner join on. So like this is a standard format that, or these are certain syntaxes that are used in order to pull out the information you want. We know about select and from. Selecting is selecting the column, and from you have to add the table name. Now we are now going to add what we want to match this table to and what columns we are going to match them based on, right? So I'm going to put the first table name here, which is customer sample, and I want that the customer sample table to be joined to the orders table, order sample, and I want this customer sample to be joined to the order sample on the unique identifier, which is customer ID. So I'm going to call out the customer table. So customer sample dot customer ID, equals to order sample dot customer ID. And I just want to see all from both tables, right? So I'm just going to put it all there. Let's run this query and see what happens. Right. So in running this query, the results we see is all the data in the customer table that also exists in the orders ID table. And from the view of the order sample table, we could tell that there were only 2 customers that placed an order, right? Looking at the results, we can see that the customer ID, customer name, and country are coming from the customer sample table, and the order ID, customer ID, and order amount are coming from the orders table. Now note that the other customers with the customer ID 2 and 4 do not exist in this join, right? So that's how the inner join works. It allows you to match rows that exist in 2 different tables. Now think of it as the overlapping point of a Venn diagram, where you have table A on the left hand, table B on the right hand, and then in the middle is the overlapping point where data exists in between the 2 tables, and that is the inner version or the inner point. So that is the data that the inner join would present once you run the syntax. Now I want to simplify the look of this query for easy readability. In my previous video, I made use of alias to represent an aggregated column or a column that I just created. With the use of joins, I'm going to use an alias to represent the tables. So with the customer sample table, I'm going to add a letter A. So A represents customer sample, B represents the order sample, right? And I'm going to change this entire code to this. So A dot customer ID, and you can tell when I started writing when I typed in A, the columns that fall in the customer sample table showed up. Once you put in the dot, and you can easily select that. Then same for B, right? So once I run this and execute, I'll get the same results. If I wanted to select specific columns, so let's say I just wanted the customer name from the customer table and the order amount from the orders table, I would type it in this way. So A dot customer name and B dot order amount. So I run this query, click on execute, and there we have the results we are expecting, which is just the customer name and the order name. So this is how the inner join works. It's giving us the data that exists in both tables that match based on the customer ID. That is the unique column that serves as the link between the 2 tables. Right. So now we are going to demonstrate how to perform a left join. Now a left join is used where you want to combine 2 tables by keeping all the rows from the left table and only matching rows from the right table. So I'm just going to show you why it's called a left join. So let me just duplicate this query and edit it. So left join. So I want to see all columns that exist in both tables. That's why I'm using the all. And looking at this, the third line, inner join order sample on customer ID, A dot customer ID equals B dot customer ID. Okay, sorry, looking at it in this format, looking at line 2 from customer sample A, inner join order sample B, you can see that customer sample or the customer samples table falls on the left hand side of the join, whereas the order sample falls on the right hand side of the join. Right, so with the left join, we want to see every record that exists in the table on the left hand side. In this case, that's the customer sample, and matching rows from the other sample table. Right, so I'm going to change the inner text to left, and run this script. So from our results, you can tell that we have all the data in the customers table that can be seen in the first 3 columns. And we can see matching data from the orders table. So data that does not exist in the orders table is represented with the text null, meaning empty, or there's nothing there or missing values, right? And this is how to perform a left join that allows you to see what is in the left table and matching rows in the right table. Right. Now, the right join is a mirror image of the left join. It's the opposite. If you want to see all data in the right table and matching data in the left table, that's exactly what you'd use a right join for. But mostly, we mainly use the inner join and the left join, right? But let me just demonstrate that. Now, since we are making use of the orders table and the customer table, ultimately all customers would exist in the customers table. So once I perform a right join, we are going to get results similar to the inner join. Right. So I execute it, and as you can see, all the data that matches, all the data in the right table, that is the orders table, and matching rows in the left table have been represented. And this is quite similar to when we run the inner join. Now this is based on the sample data that I'm using, right? Now we are going to finally learn about a full outer join, right? So a full outer join gives you all data that exists in both tables, right? So if you want to see all data that exists in both tables, we have the full outer join for that. And that is a function of the full outer join. However, the results may seem quite similar to what you see in the left join, but let's try it and see. So copy paste this code script and replace the right join with full outer join. Run, execute. Let me take the full out, run, execute, and see. It didn't work. Great. So with a full outer join, we can see all data that exists in both tables, and this was quite similar to showing all the data in the left table and matching rows in the right table, because based on the kind of data that we are using, one is a subset of the other, right? Great. So that is how to make use of the inner join, left join, and right join, and full join. And this comes in handy when you're analyzing data from 2 different sources, especially when they have a unique identifier or a unique value. You can easily use an XLOOKUP or VLOOKUP for that in Excel. However, when data gets so large that it can't fit into an Excel sheet, and you have to now analyze that data with SQL, joins come in handy, especially when you're dealing with millions of rows of transactions, right? So it's something that I believe that you need to know in SQL, right? And finally, as a bonus, I'm going to demonstrate how to perform a self-join. Yes, it's possible to join a table to itself. So let me just give an example. Let's say you have a name column in the customer table, right? And some of the customers perhaps are also employees of the company that's selling the product. So yeah, they are customers and they are also, let's say, agents, sales agents, right? So perhaps you want to perform some analysis on that and you want to reference one column with itself. You can perform a self join, and a self join is quite similar to most of the joins that we have created. It's the same syntax, nothing changes, just that table A is going to be customer sample and table B is also going to be customer sample. Right. So if I run this query, it's executed successfully, right? And you can see that we have 3 columns in table A and also 3 columns in table B. Perhaps I want to represent the customer name twice and give it different names. I'm going to say A.customer name, and B the customer name as a sales agent. Run this. Right, and the exact same column, I've represented it twice and changed one name to sales agent name. And this comes in handy when you want to, analyze a specific column or break the column down. Now, along the line in this tutorial, I'm going to be teaching us about Windows function. And Windows function is another alternative that allows you to perform data in a table by breaking it down to the granular level. So watch out for my next video and watch out for Windows functions, CTEs, and advanced SQL scripting. So that's all for this video. Thank you very much for watching. Like, subscribe, and watch out for my next video.